Okay, so we're back again with another air surface. So in this one we're going to do proportionality, but we're also going to do, we're going to wrap it in a ReLU, okay? So let's start where we left off in the last video. So I just looked myself up. Which one is it? Proportionality. So this one, if we just open an app, so let's go here. Okay. So this is where we left off in the last video, where we've got two data points here, and we've got a ReLU, and we're trying to, we just have a proportionality function, and we're trying to fit it. Okay. But this one we're going to use a ReLU around this. So normally there's also a bias in here, but for now we'll just start with the ReLU. Okay. So first thing we got to do is define a ReLU. So ReLU of x is equal to if x is less than 0, then 0, otherwise do x. Okay? And I've typed that a lot of times, as you can tell. Okay, so now here we're going to wrap this function in a ReLU. Alright, perfect. And then the one other thing we need to do, so these are our air surfaces right here, right? But x times the x value of a, this was our function without the ReLU. So now we need the ReLU around that. Okay, so let's do ReLU around, sometimes, did it throw an extra parenthesis in there? Let's see here. I think it has the right number of parentheses. Yep, that looks good. Okay, so now we're going to do one more on the second air surface, ReLU, and then put that one here. Perfect. Okay, so if I come up here, I just want to check. All right, that looks good. Okay, so I'm going to hide, well, no, let's look at the individual air surfaces. And what is this point? I'm going to get rid of these 2 points. Okay, so what's happening with these new air surfaces? You can see these used to be parabolas, but now they have this part that's lopped off. Okay, so let's just think about it. So first of all, this blue one is coming from A, point A, so that's this one. So let's just forget about B for a second. I'll forget about B, and I'll forget about the red. Let's just concentrate on this right here, okay? So what this is saying, remember, the x direction on these air surfaces is the weight value. So what this is telling us is that the weight value, let's go ahead and draw our function in here. Okay, so what it's telling us is when the weight is 0.5, maybe 0.45, something like that, we nail it, right? We have 0 error, right? But if we keep going all the way until our weight value is 0 and below, then we no longer, we flattened out, and so we have nowhere to go. There's no gradient. Okay, so let's just watch what happens. So if we kind of go down, keep going, all right, look at that, between 0.4 and 0.5, that's about our best shot, which is that's what this says. Okay, now we keep going to, now we're right about here, and if we go to 0, we're going to hit this point, and anything below 0 is not going to change. And you can see, so now everything I do below 0, that's like over here, right? So what that's telling us is the error isn't decreasing or increasing no matter how we change our weight value. And that's exactly what's happening in this graph, because when we're over here, right, it's popping this side up or down. That's not changing this error at all. So if we come back over here, now we're changing the error. But if we come back negative, we're in this zone, and so we have a 0 gradient. And I think this is referred to as a dying ReLU. I think and this happens, I think, so if we just so happen to initialize this as a negative number, this ReLU is completely dead. I mean, it's got 0 gradient, so it has no idea where to go, and it just won't pick this up, which is kind of interesting. So this is, that's what's happening here. And I can, of course, go ahead and turn on these other ones. So where is point B? Let's focus on point B for a second. Okay. Point B should have that same behavior, right? So if we go to 0, right, now it's starting to pop up on that other side, and we're reducing our error until we get to about 1, and sure enough, that looks right. But if we go down below, all of a sudden we should, I mean, that's not changing our error at all. So we should have a 0 gradient in this negative region. And sure enough, if we come up here, it has that same thing. We've got that 0 gradient in the negative region, right? And actually, if we just add them both together, as we do, this one will also have it because the two that we just added together have it as well, right? So those are dying ReLUs, and we can get a pretty good fit here. What does that say? About 0.8 is our best fit. So let's move this back up to 0.8 and give ourselves a good fit. Yeah, that looks about right to me. Okay, so yeah, this was kind of just showing how wrapping this proportionality function in a ReLU can kind of change your error surface landscape, and how you can get a dying ReLU. So, yep, thanks for watching.